Okay students, now we have seen how to do special cases example. Now we will see the method of joints, few more examples. Now next example wherein we are going to solve this as per the method of joints which we have already used for the special cases example. Now in this in this truss, you can see that we have to find out the forces in all the members by using method of joints. So the routine application that we do in this case is we have to first apply the stability criteria, find out the support reactions, and then we move ahead to find out the forces in all the members. Now the first step being stability criteria, we'll find out how many members we have. The number of members is 7. Since I'm having one hinge support and one roller support, the total number of reactions will be 3, and the number of joints, we have 5 joints. So if I put this in the stability criteria, that is m equal to 2j minus r, I should get it as a perfect truss. That means my left hand side should be same as my right hand side. So I can see that my left hand side is equal to right hand side. So I can say that this is a perfect truss. Now the next step is we have to find out the support reactions. Now for the hinge support, I'm having two reactions, one in the vertical direction upwards, I'm assuming that, and one in the horizontal direction towards right. Again, that is my assumption. For the roller support, I'm having only one single reaction perpendicular to the surface. So in this case, I'm assuming it to be upwards. So if I take this FBD and try to find out the support reactions, I should get the values for the reactions that I'm having. That is the 3 reactions. Here you can see that if I take this support reaction, that is HA, and this as the vertical reaction VA, and this as VC, since I'm not having any horizontal force, the reaction at A, the horizontal reaction at A will be 0. So that is what I got over here. Now, in the vertical direction, summation Fy equal to 0. Now I'll see how many forces I have in the Y direction. The reaction at A, VA, the reaction at C, that is VC, and the 2 forces acting vertically down. The 10 kilonewton force acting at E and the 12 kilonewton force acting at D. Now the next equation that I can make is the moment equation. If I take moment about A, this force, the 10 kilonewton force, is going to pass in this direction. So I need to find out this distance. If I get this distance, that means I can take the moment of this force. Similarly, I need to find out the moment of this force also. Now by geometry, you can see that since this is 5 meters, this happens to be 2.5 meters, I need to find out the length of EC. Now to find out the length of EC, I can use trigonometric ratios or the Pythagoras theorem. Now if I do that, I can find out the length EC. I'll just write it over here. EC by calculation, I'm getting it as 4.33 meters. Now if you want to see the calculation, what you can do is apply the trigonometric ratio over here. Now this happens to be a hypotenuse side and this is your adjacent side. So I can use the cos ratio over here. So if I do this, I'll get the value for EC as 4.33 meters. Okay, one more thing. Now, how to find out the distance for the 10 kilonewton force that is passing from this point? So I have this 2.5 meter distance given over here and this angle to be as 60 degree. So if I draw a perpendicular from this point, I can find out this distance. This angle happens to be 60 degrees. So using this, I can find out the distance at this point from here to here. So again, I'll name this point as, say, F. Now I need to find out the distance AF. So I'll just write it on the next page. Now the distance that I'm getting for AF is 1.25 meters. Similarly, I need to find out the distance for 12 kilonewton force. So for that, what I can do is, if I drop a perpendicular from this point, I can find out this distance, like from here to here. Or what you can do is, this distance, you know, this complete length happens to be 4.33 meters. So the distance CD will be half of that, and that is 2.165 meters. So now what I can do is, I can take again the cos ratio from here, this distance. I'll name this point as, say, G. So CG distance will be it will be 2.165 of cos 30. Now I can apply the moment equation. The value for VC that I'm getting over here, the value for VC that I'm getting is 10 kilonewtons and it is positive. That means my assumption, the force acting upwards, is correct. Now I have to find out the value for VA. I can use the equation in the y direction, that is VA plus VC equal to 22. So if I do that, I can put VC ka value as 10. So I'll get the value as 12 kilonewtons. Okay. Now, once I'm done with this, I need to find out the forces in the members that are given to me over here. Now, what I can do is, I can take any joint and find out the forces in the members at that joint. Now, to do that, I have told you all that you have to first identify a joint wherein you can have not more than two unknown members. So if I go to joint A, for example, the reaction force in the horizontal direction is 0. VA, I have got the value for that. This member, that is AB, is an unknown force member for me. Similarly, AE also happens to be an unknown force member. So what I can do is, I can apply method of joint at A. Now you can see that if I apply the method of, the conditions of equilibrium at joint A, what is happening is summation Fx equal to 0. So I can resolve this force, AE force, in this direction, and I can write the equation for that. And then in the y direction, if I write, so it will be FAE, this will be sine 60. So I'll get the value for AE. Since the value that I'm getting happens to be negative, I can say that this is a compressive force. Now, if I put this value of AE in the equation for X, I can find the value for AB. Now, I got the value for AB to be as 6.92 kilonewtons, which is positive. So the nature of the force in member AB will be tensile, whereas the nature of force in the member AE will be compressive. The reason for that is I got the value as a negative value. Now, so by doing this for joint A, I got the force in the member AE and AB. Now, what I can do is I can move on to the next joint. Say, for example, joint C. If I go to joint C, in that case, again, the member BC and CD is not known to me. So, again, two unknown forces. I can take joint C and go ahead. Now, you can see that applying condition of equilibrium at joint C in the direction of Y, that is the vertical direction, I'm getting the force in the member CD to be negative, and that is 24 kilonewtons. So the nature of the nature of the force in this member will be compressive. So I got the force in the member BC as positive, and the value is 20.78. So the nature of this force will be tensile. Now coming back to the original figure, I have calculated the force in the member BC and CD. So what is left out is BE, BD and ED. So what I can do is I can take joint B and solve it, or I can take joint E and solve. So in that case, I'll be able to find out the force in two members. Still, one will be left out. So you can take any member and go ahead. So for example, if I go with joint B, now once we have got the reactions at point A and point C, that is this vertical reaction along A, at point A, and the vertical reaction at point C, that is 10 and 12 kilonewtons. So what I can do is I can start with method of joints, and I can apply condition of equilibrium at any joint. But before that, I need to understand which joint I have to select. Now, in this case, if I take joint A, what happens? HA is the horizontal force for which I'm not having any reaction. Then VA, the vertical reaction, I got the value for that. The force in the member AE is an unknown force. The force in the member AB is again an unknown force. So in this case, I'm having two unknown forces at joint A. So if I take those two unknown forces and try to apply condition of equilibrium, I can find the forces in both the members. So now, if I apply the condition of equilibrium at joint A, I need to resolve this force AE. So this component would be the cos component and this component would be the sine component. The angle is already given to me and that happens to be 60 degrees. So this would be cos 60 FAE and this will be FAE sine 60 degrees. So the value that I'm getting for the force, for the member AE is 13.85 kilonewtons. And since it is negative, the nature of the force in member AE will be compressive. So I got the force in the member AB as 6.92 kilonewtons and that is a tensile force. Now once I have done that, that means I have got the force in the member AE and AB. Now I can move on to the next joint, say joint C. If I take joint C, what happens in that case? I know this force, that is the reaction force VC, that happens to be 10 kilonewtons. We have already calculated that, that is 10 kilonewtons. Then the force in the member BC is an unknown force. Similarly, the force in the member CD is again unknown. So again, I'm having two unknown forces. I can easily apply condition of equilibrium and find out the forces. So I have applied condition of equilibrium in the horizontal direction and that is giving me the equation as minus FBC, that is this force, minus FCD, the component, the horizontal component of the force CD that is going towards left side as cos 30 and there is no other force in this case, so it is equal to 0. So I got the value for the force in the member CD as 20 kilonewtons and since it is negative, the nature is compressive. Now what I can do is, I can take this value and put it in the equation for horizontal direction so that I can get the value for BC. I got the value as positive and that is 17.32 kilonewtons and that is tensile. So by doing this method of joints at point C, that is joint C, I have calculated the force in member CD and the force in the member BC. So I'm done with 4 members. I'm left out with 3 members. Now what I can do is I can move on to any other joint. For example, if I move on to joint B, so what happens in that case? This is a known force for me. This force I have already calculated. This force I don't know. Similarly, I don't know this force as well. So what I can do is I can take joint T and these two unknown forces. So I can apply the condition of equilibrium and find out the forces. Now, to find out the angles, it is very simple. The force, that is the force BD, is making an angle of 60 degrees with the horizontal. So if I draw a horizontal line over here, the angle would be 60 degrees. And since this line is making an angle of 30 degrees, the force DE will be inclined at 30 degrees, and similarly the force CD also will be inclined at 30 degrees. I know the force in the member CD, and that happens to be 20 kilonewtons. Now, since I have assumed, you can see that since I'm getting the force as 20 kilonewtons, which is negative, I need to put a negative sign here. So I have prepared the equation in the horizontal direction. Similarly, I can prepare the equation in the vertical direction as well. So now I have prepared the equation in the vertical direction as well. Now what I can do is I can solve both the equations simultaneously and find out the values in the find out the values for the forces in the members DE and BD. I'm getting both the values as negative. That means the nature of the forces in both the members will be compressive. So I can just simplify that and write it as 14 kilonewtons compressive force and 10.39 kilonewton force, again a compressive force. Now you can see that I have calculated the force in the member BD and DE. Now the only member that is left out is BE. So for that what I can do is I can take joint E and solve it, or I can go for joint B and then solve it. I would prefer taking joint B. Now taking joint B, I need to find out the force in the member BE. So I can apply the condition of equilibrium. Now you can see that I have already calculated the forces in the members BC, AB and BD. All I need to do is put in the values and find out the force in the member BE. I'll just substitute the values that I have already got. BC, it was 17.32 kilonewtons. AB, it was 6.292 kilonewtons. And BD, I have got it as minus 10.39 kilonewtons. The reason for taking minus is I'm assuming the force as an outward force, but I know that this is a compressive force. It is acting towards the joint. So I'm assuming since it is acting outwards, I'm taking the value as negative value. I've got the value for the member BE as 10.41 kilonewtons, and that is a tensile force. Now all I need to do is tabulate the I've got the value for AB as 6.92 kilonewtons, and that is a tensile force. You can check it over here. AB is 6.92 tensile force. AE is 13.85, a compressive force. If I take joint C, CD is 20 kilonewton compressive, BC is 17.32 tensile. And if I take joint B, I'm getting the values for BD as 10.39 compressive, DE, before that I'll just write for BE, I got it as 10.41 tensile. The value for DE that I have got is 14 kilonewton compressive. Okay, so you have seen that how to solve any given truss example by using method of joints. In this example, we did not get a single case wherein we can say that we can apply a special case. Now, this is how we can go and solve any other example in trusses. That is by using method of joints. I hope you have enjoyed watching this video. Thank you.